Okay. Okay, again, screen is visible now. Am I audible? Am I audible?
Yes, sir.
Yes, okay, right. Now, this slide
Yes,
is
sir.
very important for the beginners, especially to understand the difference between the machine learning model and the deep learning model with respect to image processing or anything. It's the basic slide you have to understand. So, there will be an input image, then you have to extract the features, then these are all the future vector. What is the future vector? For example, future vector consists of what? Set of features. What are the set of features? On a bike image you have seen the wheel, then you have got maybe mudguard, then you have got maybe the handle, then you have got maybe headlight, and all those things are nothing but
complex systems require analytics. Smaller, medium level systems. Okay, then you already sent in the link, right?
yeah. Am I audible? Yeah. I hope I am audible. I am continuing. This is what the machine learning model. You need to have an input image. Then you have to extract the features. Then you will be having the set of features. Then these set of features you will be giving to the traditional machine learning algorithm. Then the machine learning algorithm will give the output. If it is a classification problem, it will classify. It is a retrieval problem, then it will say whether it has retrieved or not. But usually the machine learning models are usually used for classification. That's why I'm going for a classification model only. But once you come to the deep learning, you see how it is powerful. You only just give the input image, then it itself will extract the features, then it itself will classify the image, then it will give the output. That means without knowing anything about the image, I can use the deep learning technique and I can classify the image. That's why most of the BTech students are very much attracted with these deep learning techniques, and they are trying to play with the images. They are taking the images and they are trying to classify with the deep learning models, because what they need to do is they need to give only the input image. Then automatically the learning model itself will learn how to extract the features. Then once the features are extracted, the learning model will give it to a classifier model, which is a part of deep learning algorithm. Then that classifier algorithm will classify and gives the output. So this is the beauty of deep learning. That means as a computer scientist, I always feel sad with these deep learning algorithms, because I have worked maybe 10 to 12 years to know the image fundamentals. I have developed many algorithms for feature extraction, maybe local based, global based, region based, statistical based, texture based, morphological based, a number of feature extraction methods we have derived. But today, once you have got a deep learning model, you need not necessarily to bother about those things. The learning models are very, very powerful than what we have done previously, and they extract the good number of features, good number of significant features, and those features are given to the classifier model, which is a part of deep learning algorithm. Then immediately you will be getting the output. That means try to understand this slide. This slide is very powerful and very important. That means deep learning model. In deep learning model, one need not manually extract the features from the image and need not derive methods or method for extraction of features from the image texture. That means what is the texture? Texture is nothing but a surface, that means in deep learning model, one need not necessarily to concentrate on how to derive methods for extracting the significant features. The deep learning model itself will derive the significant features. Deep learning network extract the image features automatically. You just feed the raw image. You just feed the raw image. Raw image. The deep learning network will automatically extract the features and gives you the better results than the what machine learning model does. So this is what the deep learning model. This is the car input image. So deep learning model extract the features of the car. Then it has got a classification model. Then it classifies. Then it gives an output whether it is a car or it is not a car. So that is the beauty of what deep learning or maybe neural network model. So you have to give only the image. So deep learning model extracts by itself the features, extracts itself by the features, and also it does the classification. And then it says whether it is a car or maybe not a car. That is the thing. So this is another slide I am showing. There is a bike image. So network layers are there. We'll be talking about network layers. What about these neurons and everything? I'll be giving you the brief introduction. So these are all the network, deep learning model. So in this deep learning model, what you are doing is image is being given and one of the part extract the features. Once it has extracted the features, then it gives to the other part of the network layer, other part of the network layers or the deep learning model. The second part will classify and gives the output whether it is a motorbike or not a motorbike. So this classification is called a binary classification. Now let us try to understand a little bit of mathematics. What is linear regression and logistic regression? For application where output will be a real value, that is not that comes under linear regression. For example, the price of a house, the stock market. In most of the cases, the output will be always a value, a real value. In such cases, I have to use the linear regression. And logistic regression is nothing but the binary. So for applications where the output will be a binary value, whether it is a car or maybe motorbike or maybe pass or maybe file, then I'll be going for logistic regression. I'll be talking about these things. Anyway, this is, you know, then one more thing we'll be talking about error function. In error function, most of the time we will be doing the method called squaring. So try to understand the whenever you got x1 minus x2 whole square, what is the advantage of this squaring? Squaring always gives a positive value, so the sum will not be a zero. And other thing is it won't give you a bad negative value. So squaring emphasizes a larger difference. That is the important for you. So whenever you do a squaring, maybe in machine learning model or maybe in deep learning model, usually people will think why I should square. Without square also I'll get the same difference. By squaring, what is the advantages? It always gives you a positive, and always it will say how much the difference is in terms of what from the original point. Sir, this is linearity and versus non-linearity. Okay. So, a linear, what is meant by linearity and non-linearity? Linearity means I say any straight line is a linear line. Linear line always we can give in terms of mathematics y equal to mx plus b. It gives always a linear line. But most of the time you will be getting, we have to deal also with non-linear data sets. When data sets are represented like this, maybe these are all the classes which are maybe those who are having maybe some fever. These are all the patients who are not having fever, but they are represented in terms of a non-linear model. You cannot divide them. You cannot classify them using one line. That means drawing a one line from here to here, you cannot classify them. Maybe you need to derive maybe an elliptical shape or something. So to say that these two, blue and red lines are classified. In such cases, you need to go by what? Non-linearity, not linearity. So what is the regression? To say whether it is a dog or cat, it is nothing but what? Logistic regression. So this is what we will be talking. Now we are coming into deep learning model. Okay. So now let me summarize what I have covered. I have covered the image fundamentals. Then I talked about gray level image, black and white image, and the color image. Then I have talked the important concept of any image processing is the feature extraction. I have given you what you mean by a feature. So whether then what you have to do with the features is you have to extract the significant features, and that is very very important. Then I have given you how a machine learning model will be. Then I have given you the difference between a machine learning model and a deep learning model. Now I am taking you into the deep learning model, and also I have talked about regression, what is a binary classifier, and what is logistic regression and regression. Just I have given you, and also I have given you one terminology, what is the importance of what squaring. Anyway, squaring and other things are needed for you, but anyway, those things let us now leave. Now coming to the deep learning model. Now here this is very important. In our brain there are neurons, n number of neurons. Not only n, can be infinite also. We don't know how many number of neurons, so that's why I'm saying it is not infinite, definitely finite, maybe some thousands or lakhs of neurons we will be having. So whenever a neuron receives a signal, then immediately what it does is it passes that signal whenever it reaches a saturation point or whenever it reaches a threshold. This is very very important. What is this? Is called an activation function. That means whenever a neuron receives a signal, once that electric voltages, we call it as electric voltage, once that electric voltage reaches beyond some threshold, then that value will be passed to the next neuron, and the next neuron will be taking some decision. What is this threshold? It is very difficult to understand, but is very much needed for a deep learning engineer or deep learning scientist. What is this threshold? Simply, I will say, now you are assume that you are somewhere and there is a table. Once the table is, you assume that you are at some other place. I'll give this kind of example. Then there is a hard surface. You have placed your hand on the hard surface, but the surface is around only 20 degrees of heat, but it is not much heat. Then you will keep your hand on that hard surface for 2 to 3 minutes. Then maybe after 3 to 4 minutes you will say that okay, it is a little bit going heat. Then you will remove your hand without any noise. That means you can bear that temperature for 3 minutes. This is called the threshold. So you are bearing the temperature for 3 minutes. After 3 minutes you are activating and you are removing what? Your hands. Now assume that the second scenario, now the table, now the surface is of around 80 degrees of heat. Assume that you have kept your hand. You immediately will say, oh, it's very hot, and immediately you will remove your hand. That means what it is, the threshold immediately. That means whenever the threshold is beyond 40 degrees, immediately you will remove your hand. But whenever the surface is around 20 degrees, you will keep hand for some time. After some time, you will remove. This is called the activation function, when you will become active. And the activation function is different. Assume that you are with 5 of your friends. The other way I will tell you, you are with 5 of your friends. One friend will be scolding you. You will keep quiet. Oh, this fellow is anyway my close friend. He'll be always like this. Even though he started scolding you for half an hour, he'll be laughing at you by playing jokes and other things. You will keep quiet, and because you have got a good frequency, that means your threshold level may be very high in terms of that person. But if at all some other guy comes and says, hey, some jokes on you, then immediately you will try to retard him. That means these weights, these thresholds are different from person to person, because some person, if at all he says to me something, I will listen, I will say obediently, though he is joking on me, though, but I will keep quiet. But if at all any other person comes and jokes on me, then I will try to retard. That means each and every, if at all you think all of your 5 friends are your inputs whom you are talking with, one friend, your tolerance factor is very high. That means whatever he says, you will keep quiet. But with the other friend, your tolerance factor is very low. Whenever he says something, immediately you will react. What is this tolerance factor? This tolerance factor is called as weight. This tolerance factor we call in deep learning as weight. The tolerance factor on a hard surface of 20 degrees is for me 10 minutes. So this 10 is called the weight. But the tolerance factor, when I keep my hand on a surface which is of 80 degrees centigrade, then immediately the tolerance factor is 1 second. Within 1 second, I remove my hand. That means the weight of that is 1, but the weight of what? The other hard surface is maybe 5 minutes. You see, these are called the weights. So here one is the weight. There 5 into 5 minutes means 5 into 60 seconds. The weight is 300. So these the weights are very very important whenever we talk about the deep learning. But mostly people may not be understanding what is these weights. Weights for each and every input will be different. I'll be throwing more number of examples on these weights. So these are all the things. That means you are the f of x, then you will be receiving what people will be talking about you, something. So based on that you will be generating an output. So this is what we are going to talk now, nothing else. It is now, what is this is what a neuron. What neuron will do? It receives electrical signals from its dendrites, then modulates the electrical signals in various amounts, then fires an output. When it should fire? Whenever it reaches certain threshold. This is what I said here. Whenever it reaches certain threshold. Whenever the strength of the input signal exceeds a certain threshold, then it fires. That means neuron receives an electrical signal. When it fires, whenever the signal receives certain threshold, then only it fires. The same example I have told. The output is then fed to the another neuron and so forth. This is what I have shown. The example, hard surface. This is what, whenever you are touching a teacup, which is very hot, but you'll always keep your hand like that because tolerance factor, the weight is heavy there. But whenever while ironing, if at all the iron box touched your hand means, immediately you will say, oh, it's very hot. You will remove. That means what it means, the tolerance factor is very low. This tolerance factor in terms of seconds, I am calling them as weight, nothing else. This is called the artificial neuron. So in deep learning, we will be calling the artificial neuron, and otherwise people may call it as a perceptron. So this is the diagram of what perceptron. So this is the perceptron. It calculates the weights. Okay, I'll go here. Yeah. Now I'm showing you another beautiful example. You wanted to calculate the price of a computer. You wanted to calculate the price of a computer, or the price or the significance of a computer, whether it is significant or not. Then what factors you will see? These are all the inputs. X1 is the screen size. You are giving weight 1. The weight 1 is you are giving, what is its weight is 2. The tolerance factor I said you are giving 2. Then hard disk you are giving a weight of 6. Then processor speed you are giving a weight of 20. Then the RAM size you are giving a weight of what, 15. Then battery timings, that means you are giving a weight of what, that means W5 you are giving 1. Then you have got a bias. I will be talking about bias. I am thinking that it is one more input which is not at all related to with all these 5 inputs which are needed to, to buy a computer. But this is one more bias we'll be talking later. Y equal to mx plus b. That b is here to say that it is a linearity. To become it as a linear, we will be using the bias that we'll be talking later. So now what are these weights? So these weights, that means I have seen a computer, then you will say it's a large screen, it is having a hard disk of this size, but processor speed is low. Then I will compute processor speed, it is low, then I will multiply with 20, then I will be getting a low weight. That means I will say that all these things will be coming. Then I will have an activation function. If at all, the activation function says, if at all by multiplying these weights with these inputs reaches some certain threshold, let us say 120 or something value I'll give. If it reaches that, then only I will activate this. So this is nothing but what? A one neuron. This is called, I am already in the deep learning. Try to understand. Try to understand. I am already in the deep learning. Deep learning is having Z1 is a neuron or perceptron. It receives signals from the inputs, but these edges will be having the weights I am giving here, but the deep learning automatically gives these weights, how it gives and other things we'll be talking slowly. So these weights are also taken by whom? By the deep learning model only, but there is a system how to give these weights also. That means now next see the other example. This might be more easier for you to understand instead of this. This one. Now assume that You have got 5 units to study to pass an exam, to get maybe good marks, distinction marks, or maybe whatever marks. Now, what happened is a student came to me at the end, maybe he's a good student. Then he came to me and said, "Sir, somehow I have missed most of your classes due to ill health and due to other problems at home. So now I have not studied this subject." That means he came to me 1 week before the exams. Then he asked me, "Sir, show me a method so that I can easily pass the exam. But I want to study only, not by malpractices." Okay. Then I said, "Hey man, student, you look, if at all you study unit 1, you will be getting only 6 marks. That means I know that the only 6% of marks only will be coming from unit 1. Then if you study unit 2, then you will be getting 19, maybe around 19 marks you may get. But unit 3 is very, very important. That's why most of the time 40 marks questions, 40 marks will be covered from unit 3, or 40% of the marks will be covered from unit 3. Then from unit 4, 25% of the marks will be covered. Then unit 5, 10% of the marks will be covered. Then I'll ask the student to go through, unit 3, then unit 2, which is having 20 or 19 marks, and also unit 4. You concentrate on these 3 units very well. Definitely, you can pass the exam. Now, you may ask, how I arrived about these weights? Unit 1 weight is 6, unit 2 weight is 19. For that, this is the answer. This is the answer. So what I have done is from 2010 to 2019 question papers I have gone through. Then I have seen in the unit 1 in 2010 only 5 marks came. In 2011 only a question of 8 marks came. In 2012 only a question of 2 marks have come. So from 2010 onwards I have calculated how many marks on unit 1 are coming. Then the average came it as 6.4. So I have given a weight of unit 1 as 6. Try to understand how to calculate weights by us. Then on unit 2 also I have got in 2010 there are 18 marks of questions came. Then in 2011 22 marks of came in unit 2. Then totally I have made it as an average, it is 19.4, it is 90. Then unit 3 came as 39.6, so I have given 40. This is how I have calculated the weights. This is what I have told to student. Now here I wanted to explain the activation function also. Now I ask the students, so better you go through by unit 2, unit 3 and unit 4. Then the student came to me, "Sir, I have studied unit 2, unit 3, unit 4. Then I'll ask him, to how much percentage you are confident on unit 2? He says, "No, sir, unit 2 I have studied, but still I have got 1 or 2 doubts. I think so. I am maybe 80% I am okay. Unit 3 I am okay with 100%. Unit 4 also I am okay 100%. Then I will calculate 40 plus 25 is 65 plus maybe 10, maybe something like 75. Then this is G of Z1 activation function. Now I will say whenever my total comes, whenever my total comes 70 or above, then only I will say the prediction. Then only before exam I will say, student, oh, you will definitely pass the exam. Student, you will definitely pass the exam, because he has told me that he has completed the unit 2, unit 3 and unit 4 thoroughly. That means I have calculated, okay, 70% of the mark he may get, but pass mark is only 50%. Even though if it goes a variation of this way, that way, definitely you will get pass mark of 50. Then I will say, okay, you may be passed. Then second student also will come to me. Then also I will ask the same questions. Based on that, I will be predicting, maybe I will be predicting in advance before going to the exam itself. I will be predicting myself, okay, this student will pass, this student will fail, this student will pass. Then what I will do is, once the results comes, then I will try to verify how far my prediction is correct. If then I will say, if my prediction is giving me 95% of the result, then I will say my weights are excellent. Then I will say my weights are excellent. What is the base of my model? Base of my model is the weights, how I have calculated. But assume that the success rate is only 40%. That means something is wrong with my weights. Something is wrong with my weights. I am assuming that students are good. They give me the right thing. If at all they have studied unit 3 means they will say thoroughly what percentage that I am taking. That means if at all the prediction is wrong means I will think that something is wrong with my weights. So I will try to change the weights also, because though I say unit 3 is 40%, 40 marks will be giving, but out of 40 marks, most of the time there will be difficult questions. So though you study unit 3 maybe in the last 3 days, you may not score well. Then what I will do is I will reduce for unit 3 maybe the weight, and I will try to adjust the weights, and I will try to see whether I will reach the 85% or 90% of the prediction. So try to understand, this is pass or fail. I will initially I will predict. After predicting that, I will calculate the error. Error means how far my prediction has come true. If my prediction has come true 90% of the time, that means my weights are excellent. The way I have calculated the weights are excellent. If my prediction rate is coming below 50 or below 75% means I say my model is a failure, then I have to readjust the weights. Your deep learning also internally, it will readjust the weights. Then whenever the prediction rate, whenever the final, error rate is high. That means what a deep learning model now, the deep learning model will be having so many inputs. From those inputs, those inputs are connected to what, one of the connected to a neuron. Then you will be, the deep learning model will be assigning weights to all these edges. Then it will do the summation means x1 w1, x2 w2, x3 w3, x4 w4, x5 w5. I will say all my inputs are having a value of 1, so I multiply 1 into 6 means I will be having 6, 6 plus 20 and so on. This is the summation. Once, then I'll have an activation function. What is this activation function? If it is above 70, I'll say pass. If it is less than 70, I will say it is fail. I will say it is fail. Based on that, I'll calculate this one. And sometimes I have to change my activation function also whenever my error rate is high. Because I said above 70 is pass, then below 70 is fail, to be on safe side. But now I have seen that most of the students whom I have predicted that he is going to fail, but they are passing. That means now I have to reduce my threshold from 70 to 60. Then I have to see, then in that case also, the model can correct the errors. So now, not all input features. Now, what you people have learned from this is there are so many input features: x1, x2, x3, x4, x5, but all of them are not significant. Only few of them are significant. Here, which are the significant inputs? x2, x3, x4. So once you will be giving to those significant inputs higher weights. So wherever you are giving higher weights, they will dominate the entire process. So some inputs are made more important than others. How to say that? By giving them more weights so that they have a greater effect on the output. So this is a simple statistics on the weight. If the weight is high, it amplifies. If the weight is low, it diminishes. But how to choose the weights is that depends upon your experience. But in common representation of neural networks, the weights are represented by lines or edges from the input node to the perceptron. This is what I'm saying. How the weights are represented by edges. That means each edge is having a value. What is that value is called as a weight. Each edge is represented by a value. What is that value is called weight. So now single, that means I am talking about a deep learning model with only one perceptron or one neuron. This is the perceptron. So what it does, it receives the inputs. It receives the inputs from n inputs. It receives. Then each input will be having a weight. Then it will sum all those weights. Then it gives to the activation function. Activation function is having a threshold. Once it is higher than that threshold, it says 1. Once it is below the threshold, it says low. Then that is the prediction. We'll say yes is going to pass, yes is going to fail. Then compares the prediction with the correct label. Whether I said pass, whether the student has passed or not. I said fail, whether the student has failed or not. Then we will detect the error. Then we will detect the error. So once we detect the error, then we will see if the error rate is very low, 0.2 or maybe 1% or 5%, then I'll say my prediction is very high, my model is excellent. But if the error rate is very high, if the error rate is 40% or 60%, that means my prediction is poor. Then what I have to do is I have to adjust the weights, and also sometimes I have to look after with the activation function. So it is clear. So what is basically a deep learning model? Deep learning model will have inputs. Each input will have a weight, and that will be given to the neuron. Neuron will sum all these weights. Then it will be given to the activation function. Then the activation function will give the output, whether it is whether it is pass or fail. Once then at the end, after the predictions, I will test many students. After testing with many inputs, then I will calculate the error. If the error is high, then I will try to readjust the weights or maybe the activation function. This is basically a deep learning model and nothing else. But now I will elaborate. Instead of one neuron, I will say 100 neurons. Instead of one layer, I will say 100 layers and nothing else. Instead of one neuron, now I'll say what? Many number of neurons. Instead of one layer, I'll say hundreds of layers, n number of layers, and the concept is same, and the activation function will be the same. And the activation function, there are n number of activation functions. I'll be talking about few of them also. Here the activation function, I have chosen it randomly, 70. I have chosen it as what? Randomly. But randomly choosing may not be good. There are mathematically derived activation functions. So I'll brief you a few of them and nothing else. So this is what a deep neural network. You have got the inputs, LOC, LO1s, X1, X2. You have got the inputs x1, x2, x3, three inputs. Then the first one, blue one, 1, 2, 3, 4. This is called a hidden layer because these layers are not visible to you. That's why we call it as a hidden layer. This hidden layer is having 4 neurons. One neuron, two, three, four. Then you have got one more layer. This layer is shown you as with what blue color. This is called also hidden layer 2. The hidden layer 2 is having how many neurons? 4 neurons. Instead of one neuron, in each hidden layer, you are having 4 neurons. How many hidden layers you are having? 2. Is it a rule, thumb rule that deep neural network should have only 2 hidden layers? There is no thumb rule. You can have as many as hidden layers. You can have as many as neurons in each hidden layer. You can have as many as inputs. You can have as many as outputs. What is an output? If at all you wanted to say a binary output means a pass or fail, then you need to have only one thing. If it is 1 means I'll say pass. If it is 0 means I'll say fail. But maybe you wanted to classify maybe 10 digits, whether it is a digit 0 or 1 or 2, then you will be having here how many outputs mean output layers means output layer you will be having 1, but it will be having 10 neurons. Each one will say whether it is 0, and if it is next one is 1 means you will say it is 1. That is what I am going to show you. Is it clear now? You will be having hidden layer 1. Here I have shown you hidden layer 2, but in a scene you can have any number of hidden layers, any number of inputs, any number of outputs. In each hidden layer you can have any number of neurons. Weighted sum function. It is the sum of all inputs multiplied by their weights, then added to a base term, bias term. So the function produces a straight line. This is what is very, very important. That means whenever you are doing this summation, it produces you a straight line. But the straight line we are taking with the help of what? Little bit linear algebra. We are going the straight line as what y equal to mx plus b. That is nothing but I'll show you this straight line. Yeah, this is the straight line. Let us see. This is the straight line y equal to mx plus b. M is the slope. And what is the b? Bias. Bias says that it is the part where it cuts the y-axis. So that is what I am going to talk about the bias. What is this bias? Because this is the B. B is the bias. That is what I have added. What you are actually getting, you are actually getting Xi into Bi. Sum of what? Each input with its weights, you are getting X1 W1 plus X2 W2 plus X3 W3 plus Xn Wn. But you are adding this B. Why we need to add this B? To get the more and more of linearity. I will show you this. The function of a straight line is represented by y equal to mx plus b, where m is the slope, where b is the y-intercept. That is what we know from intermediate maths. That is y is the intercept. The bias is the point on the y-axis. What is the bias? Bias says that it is where actually cut the y-axis, touches the y-axis. So the bias is that point on the y-axis. The advantage of bias is it allows you to get the more and more of linearity. It allows you to get the more and more of linearity. It allows you to get the more and more of linearity.
Sir? Hello, sir. Sir, Vijay Kumar, sir.
Audio. Sir, Vijay Kumar, sir. Cut అయింది. Due to some technical error, speaker's system is logged off. Kindly be patient. Yes, speaker has been logged out. Kindly be patient. Good morning, all. So, speaker has lost the internet connectivity. So, kindly be patient. He will connect in 5 minutes. Thank you.
Yeah, is it audible?
Yes, sir, audible.
Is it visible, my screen?
Yes, sir, visible, sir.
Okay, your session. Initiation. So try to understand the bias from whatever the knowledge you have got gained from your intermediate. Don't try to focus much. What is this bias function? What is this B? Still you have got a doubt after this. Open your intermediate or maybe basic fundamentals of the line equation y equal to mx plus b and the purpose of b. Why b is there? So the same purpose here also we are keeping the b. So the major. So still you are having any doubts because mathematics sometimes some people might be feeling that once I write an equation, it's difficult to understand. The simple mathematical equation y equal to mx plus b. What is the purpose of b? You have to understand. Bias only influences the output values. It doesn't interact with the actual input data. That means slope is different from the bias. That is what you have to understand. Now, is one neuron enough to solve complex problems? Because I have shown you initially with one neuron, then I have shown you with a deep learning model with n number of layers, and each layer will have what? Multiple neurons. The perceptron is a linear function. Single perceptron gives me a linear function. Any perceptron is a linear function. This means that the trineuron will produce a straight line that separates our data. This is now one perceptron produces for me one line that separates these data. That means red and blue I have to classify. Then I will try to draw a line with y equal to mx plus b. That is what the neuron does, because the threshold, it says this is the basic threshold. So this side it will say yes, this side it will say no. Otherwise the other side it will say one, the other side it will say no. Now assume that you have got a data spread like this. Red data is spread like this and the blue data is here. If you draw one line, neuron 1, here you see, if I draw with neuron 1, then I cannot separate. That means error rate will be high. This side is red. If at all I say this side is blue, but even the red dots also will be present. So many red dots also will be present with the blue dots. So now what I have to do is I need to draw two lines. Forget about your neurons and everything. How to classify them, how to differentiate them with two lines. Try to understand like this only, how to differentiate them with two lines. So now I have drawn another line. This I am calling it as a neuron 2 line. So neuron, now I have got two lines. With these two lines, I could able to separate. That means when you compare this data, that is this slide data, when you compare this slide data, now you can try to, you will be knowing that the second slide data, this data is more complex when you compared with this data. With this data, you can easily separate with one line, but whereas this is complex data, you need to have two lines. Now let us see one more kind of data. You have got this is what I have shown. One line, it is I mean, simple data. It is a little bit complex data. So to classify them, to distinguish them, what is the meaning of classification? It means to distinguish them, I need to have to draw two lines, and each neuron will give me a single line. So I need to have two neurons. Then a single perceptron works great with simple databases, with simple data sets. But whenever you need to, I mean, differentiate much more complex data, then you need to have multi-layer. So from this, the word multi-layer perceptron. That means each layer will have multiple perceptrons. So that is nothing but what? Multi-layer perceptron. Now assume this side here, you have got a more complex data, which is of triangular shape. Red dots are covering over, red dots are over blue stars. Red dots are over blue stars. This is more complicated data. Now how to separate this red dots against what blue means? Then again, you have to go maybe three lines. You have to go maybe a three lines. So that means now in this case, that means these lines will be in the shape of what? In the shape of what? These lines are in the shape of what? Triangleish. This means this is forming a triangleish. So that means you will be having a neuron 1, hidden layer only 1. You have got how many neurons? Neuron 1, neuron 2, neuron 3, and you have got two inputs. Why two inputs? Because your inputs are red and green data, red and blue data. Otherwise, circular red dots are shown in terms of circular shape, and other one blue, or maybe I think so green. I think it's blue only. Blue are shown in terms of what? Star. So you need to have only data of maybe red, you can assume that dogs, and blue, you can assume them as cats. So you have got the blue and cat. So all of them are connected to three perceptrons, 1, 2, 3. X1 is connected to perceptron 1. X1 is also connected to perceptron 2. X1 is also connected to perceptron 3. X2 is also connected this. And this is the output layer. And these three are connected to this output. So this is also called as a fully connected one. Fully connected architecture. It is called fully connected. That means all inputs are connected to all neurons. There are two inputs. These two inputs are connected to, I mean, all the three neurons, and all the three neurons are connected to the output layer. We call it as a fully connected or some kind of mesh network in terms of what? Computer network. So this is what a small neural network I have shown you with a non-linear data. You have got this thing, but sometimes data will be more and more complex, so you need to go by a non-linearity. So how to achieve non-linearity? This is multi-layer perceptron. You have got maybe two inputs. How many layers you have got? This is 1, 2, 3, 4, 5, 6 layers, and each layers you have got six neurons. This is one of the model. A neural network model can have more than one neuron with more than one hidden layer. So many questions will be coming. How to select the number of neurons in each layer, and how to select the number of hidden layers, whether I should have 1 or whether I should have 2, whether I should have 3 or whether I should have 4, whether I should have 5 or n number. How to choose this? That's a big question. I'll try to answer slowly. So activation function is also referred to as a transfer function or non-linearities. What is an activation function? Activation function is also called as a transfer function. Try to see activation function is called as a transfer function. Whenever student, if at all he says, whenever student has given me the weights, with these weights I have calculated, then I will send to the activation function. If it is beyond 70, I will say above or equal to or beyond 70, then I will transfer that function, that weights as what pass. Otherwise I will say it's a fail. That means activation function is also called as a transfer function. What they transform is the linear combination weights into non-linear models. That is the purpose of here, the activation function. What they do is the linear models, they will try to convert them or transfer them into non-linear models. Why we need to have non-linear models? Because sometimes data will be too complicated and you need to classify them, then definitely you need to have what? Non-linear model. Why to use activation function at all? Why can't you directly transfer whatever you receive? The purpose of the activation function is to introduce non-linearity. That is very, very important. Without it, a multi-layer perceptron will perform similar to a single perceptron, no matter how many layers we add. That means without activation function, your deep learning network will act as a, or your neural network or your multi-layer perceptron will act as a, linear model, but it never becomes a non-linear model. And in fact, how many number of activation functions are there? There are infinite number of activation functions are there. Today, a lot of research is going on activation functions, but I will try to show you few of the activation functions and what are those things, how they are. Okay, now I'll take some time for doubts. Then if time permits, then I'll go into this. Otherwise, it will take more time now. If answer is start this again, I need maybe 1 hour. So let us try to go with the doubts. So any doubts you are having? So doubts can be asked.
और ये वेब बेस्ड और बिग डेटा में इसने कोविड-19
Good morning, sir.
शशांक
Kindly be on mute.
मुझे बच्चे दे शशांक खुद ही खड़ा हुआ था सर ने कहा कोई मुझे बच्चे दे शशांक ने कहा हाँ सर है मुझे तो अमित गोयल का भी सही लगा है एक उसका वेब बेस्ड है
और ಇದು video
Hello, good morning, sir. Hello, good morning, sir.
Sir, Vijay sir.
Yeah, good morning. Good morning.
Sir, how to train our neural network, sir, for a better output?
For a better output, training means you have to give more number of images and you have to adjust the weights. There are, how to select the weights. There are also models. That he function is there and other functions.
Hello. Hello.
Am I audible?
Audible, sir. Good morning, sir.
Yeah, good morning.
Sir, thank you for the informative session. Can we have your PPT?
Yeah, that you ask the organizers,
Okay, okay. Thank you, sir.
So I have thrown light on basically what is deep learning, because I need another 2 to 3 hours to cover the remaining part. So here I am stopping. Any doubts I would like to take care.
Hello, sir.
Yeah.
Can we know about gradient functions?
Yeah, gradient function. There are gradient functions. I said error function. You remember I talked
Yes.
about error function. Whenever the
Yes.
prediction is low, whenever the prediction or error rate is high, then I have to adjust my weight.
Okay.
If the weight is around 6, for example, I have given for unit 1, the weight is 6. If I made it to somewhere about 20 or 30, then what I am doing is I am adjusting my weights at a far distance. Then automatically what will happen is my prediction also will be oscillating. Previously it might be 40, it may go to some other percent, or it may become so and so. So what is the gradient descent is, it's a mechanism that will say how to alter these weights. There is a step function, and also gradient descent will guide me how to alter these weights. That means you try to adjust the weights of this at a low phase, or maybe try to adjust these weights at a high phase. So gradient descent function is useful because it works on the slope. That is the thing.
Hello, sir.
Yeah.
Sir, can you explain about the long shutter memory? What is the role of long shutter memory in text classification in social media like Twitter and Facebook and also?
What is
it
that?
suitable? LSTM.
Long?
Short-term memory, LSTM, one of the deep neural learning technique.
Long short memory.
Yes.
No, I think so. It's a memory which will be there for a short time, but the capacity might be more. That might be.
Yeah. Okay. Thank you.
Thank you.
Sir, can you please differentiate between neural networks and deep belief networks?
Neural networks and
deep belief networks.
Yeah, see, neural networks and deep belief network complexity will be high. See, once I go high level of complexity, then differently, that means instead of 5 layers, if I go somewhere about 60 layers, and in each layer, if I go by more number of neurons, then definitely I can classify better. That is only the difference, the complexity in terms of complexity.
Okay, sir. Thank you, sir.
Hello, sir. Good morning, sir.
Yeah, good morning.
Very informative, sir. Thank you very much to Anurag University. We got today's session is very nice. Sir, my question is, multi-layer perception is applicable only, it is either in the linear and non-linear data, sir. It is applicable for both or especially for non-linear?
Both. Because of the activation function, see, activation function I have not gone through. I mean, I just given it. Because of activation function is there with each neuron, perceptron otherwise. So what activation function does is, it converts the transforms the linearity into non-linearity. That is one thing. And the second thing is, the basic disadvantage with multi-layer perceptron in terms of, digital images is, we have to give images in terms of one-dimensional only. Multi-layer perceptron cannot take the inputs whenever it is in the two-dimensional format. So we have to give the images in terms of what? One-dimensional. And moreover, they are mostly fully connected. Multi-layer perceptrons are mostly fully connected. Once it is fully connected, then the complexity is very high. That's why we go for into what? Other kind of networks. That is the thing.
Yes.
Hello, sir.
Yeah.
Good afternoon, sir.
Yeah, good afternoon.
Sir, as the number of layers in the network increases, so the cost also will increase, sir, or it will be, it is good or bad, sir, to increase the number of layers, hidden layers inside the neural network?
Yeah, see, initially it will increase. Later you can also do the dropouts. So initially I will try to have more number of hidden layers. And in each hidden layer, I will have maybe 10 to maybe I'll have somewhere about 64 to 512 neurons. So it's a big complex. But later, what I will do is, if at all I am achieving a good accuracy, then what I will do is I will drop out some of the layers. It is something like this, you know. Initially, I wanted to do a project. I will hire 10 people, and I have to complete that project within 15 days. But with 10 people, I could able to do the project within a week. So next time, whenever I am getting a project of 15 days, though I have got 10 people, I will only try to give that project to only 5 persons. Remaining 5 persons, I will allot to some other task. So this phenomena is called dropout. So though you have got 512 neurons, you may not be using all neurons. So those connections will be made as what neutral. So that means those neurons won't pass anything to other neurons. So you can say some of the neurons will be dropout, but your structure remains same. So you need not necessarily to remove. Your structure remains same. Whenever you want, you can use.
Oh, okay, sir. Thank you, sir. This is Srinivas, sir. This is Srinivas.
Yeah, right.
Thank you, sir.
So in YouTube, a few participants has asked the question, sir. Shall I ask?
Yeah.
Can we take negative values as weights?
Can you take?
Negative values as weights.
As?
Negative values
Negative values as?
Weight, sir.
Weights, negative values, usually we won't take, madam, but anyway, you can give negative, nothing wrong.
Hello?
Okay.
You can take negative values, but how?
Okay, sir. So one more question here.
ఏమో రాత్రి నిద్ర చేయమని చెప్తే వాళ్ళు ఊటినట్టు కూర్చొని వచ్చారు.
Yeah, please.
Okay. The next question asked is how to detect the object, which algorithm we have to apply in better way.
See, once you go with the deep learning, you need not necessarily to bother about what algorithm you have to do. You give the image, it itself will learn. The first hidden layer will try to detect what? Maybe the patterns. Second hidden layer will detect patterns within a pattern. Third hidden layer will try to detect patterns of second layer. Within that patterns, it will detect what? Micro. Initially, you will be detecting macro, then macro to micro, micro to micro, micro to submicro, submicro to mini micros. The patterns will be detected like this, and based on that, it will try to this. But if at all you wanted to go for an image processing side, you are not using deep learning, you wanted to go with the machine learning, means you have to work hard on detecting what? This thing. But since that depends upon the object, you know. If at all I wanted to recognize faces, I will use some other algorithm. If at all I wanted to detect means a car, I will use some other algorithm. So these things cannot be common, you know, for all the things. That is the thing. Detection, I am talking about detection. I am not talking about classification.
Okay, sir.
Hello, sir.
Yeah.
Like I want to know, like in machine learning, we use a lot of feature engineering and everything, so that domain knowledge is also important.
Yeah.
But in neural network, we don't need to do anything with feature engineering.
Yeah, that's true. That's what the task made very easily, you know, very easy. That's why even third year students and final year students with Keras and other things, they are using a deep learning model, which is already existing. There are several models of deep learning model, and they are able to classify.
Okay, then what is like, which one will be better, neural networks or machine learning? Because in machine learning, we use domain knowledge, but here there is no domain knowledge, like everyone can apply.
Which one is better, cell phone or ordinary phone of 20 years back for you?
Okay, you are comparing
Cell
old
phone. Now the technology, see, I said as a computer vision man who worked for 25 years in this field, but I always feel bad about the deep learning because nobody is learning the basics. But here you need not necessarily to learn the basics. Directly it will go. Once the MATLAB has come, directly once you say image means image will be formed. But when we have done, we used to create an image with those data using C language. We used to write a program for creating the image also. So now with these packages, you need not necessarily to bother about. I mean, people will say those are all the small things, but people like me will say the fundamental things. So now with the deep learning, you don't require much of domain knowledge. That is true.
Thank you, sir.
Yeah.
Sir,
Yeah.
so what is the exact difference between TensorFlow and then Keras?
The difference is only thing, number of hidden layers, number of neurons in each layer. You are only talking about these two. There are many. ReLU is there, many is there. You put all those things at one place and you see, then you'll be seeing the difference only is what? Number of hidden layers, number of maybe neurons, and number of the other functions. And that is the thing. Whereas TensorFlow is a fully connected, talking about artificial neural networks, they have got other functions like maybe they, they have got maybe convolution is there because they extract more number of features with the convolutions because they can have 16 to maybe 64 filters that are called as a convolution filters. And again, you will be having pooling is there. Then you will be having overweighting is there. So many features are being added to them. That's why I say that they are maybe much better.
Okay, thank you. Are there any command to know exact one particular library's function? Suppose I want to know in hidden functions of TensorFlow. Are there any command something instead of going description of TensorFlow?
I think so. There is no hidden command, but you can see the number of parameters.
Okay, okay. That can we get this through some command line something?
Okay, by giving maybe with Keras and other things, once you say display means architecture, it will display what? The number of parameters, but parameters you can calculate by looking physically also, by looking at the architecture.
Okay, thank you.
Participants still have...
Hello, sir.
Hello.
Hello.
Yeah,
hello.
please.
Sir, can I ask one question, sir?
Yeah, you are audible, please.
Yes, sir. Sir, we are taking here for weights every time randomly, sir. Is there any method is there automatically to calculate every time trial and error and taking it will take a lot of time, no?
Yeah.
To evaluate this.
Yeah, there are things like HIST and other things are there. I mean, usually, neural networks will take from that. You can see, just Google it, how to ascertain weights in deep learning. Then you will be having various methods. How it takes, that will be given there. There are methods like HIST and other things. Usually it will be taken by that only, by them only. That is one of the popular one.
Okay, sir, my question, sir, this is the then artificial neural networks, what you said, and deep learning. Then what is the interlink between these two, sir?
Artificial?
Sir, ANN and DL, sir.
Deep learning. See, both are same. See, artificial neural, thing is, whenever we say deep learning, artificial intelligence, deep learning is a sub-branch of artificial intelligence and so on. Now, once I use the deep learning, you won't be seeing anywhere the component of artificial intelligence at all, because it itself will do internally everything. Deep learning and artificial neural networks, we use, sometimes I use deep learning method, sometimes I will see what artificial neural networks. So there won't be any difference. Artificial neural networks will use what? The deep learning model otherwise.
I think both are same, sir, but depends on the layers what you have used.
Yeah.
Okay. Okay, sir. Thank you.
No, what you have to do is there are different types of deep learning models are available, or artificial neural network models are available. You just see them. No need to keep your brain much. What will be their number of hidden layers you see, number of neurons are you see. Then there is a comparison also available in the Google, and why is particular deep learning model is more powerful than this. They will be writing that. So now you can easily compare. Once there are more number of neurons, once there are more number of hidden layers, they say it is powerful. There may be convolutions are there. You try to understand what is a convolution, basically going through the image processing and other things.
Okay, sir.
Thank you. Good afternoon, sir. Sir, good afternoon, sir. Am I audible to you?
Please.
Sir, I have a question. When we are training a deep learning model, At the last layer, we are getting a particular class label as output. If we want, for example, for a particular piece of text or some image, we want to generate 2 or 3 labels. How can we do that, sir?
Yeah, 2 or 3 labels means your question might be this. Maybe input is a digit. I have to classify whether it is a digit 0, 1, 2, 3, 4, 5 or 9. Am I right?
No, not like that, sir. For example, I'm having a piece of text like some tweet. I want to classify it as sorry. I'm having a movie review. I want to classify it as action, adventure, horror, humor, like that. I'm getting humor, horror, both. How can I do that, sir?
That means you are, you wanted to classify into 5 or 6 types. Am I right?
Yes, sir. For a particular statement, there may be 5 types, or for some other statement, it may have only 2 labels. For some other statement, it may have only 3 labels.
Yeah, based on the probabilities, based on the probability distribution, you can do that. Because I say it is, one, I'll say, saying that it is horror movie in class 1, then I'll give the probability. Then I'll give you regression model, I'll go, then I'll say that whatever maybe it is also having some comics or something. So based on the probability to what, how much percentage it is of, horror is there, how much is of comics are there, how much of what maybe some other things are there. Based on those things, you can evaluate. It gives that.
Oh,
no doubt.
Okay, sir. Thank you, sir.
Participants, still any questions, please?
Sir, I'm Sumitra here.
Yeah.
Can I ask you one question?
Yeah, please.
Yeah, so thanks a lot for that very interesting and informative session. Sir, when we are using these activation functions in this MLPs, finally they will actually contribute towards increasing the accuracy of the classification process or the prediction process. Is it so?
Yeah, definitely. That's what I said. That depends upon both the things, activation function and also weight adjustment.
Okay. So,
you can check any model, they will say usually you use ReLU or maybe some other thing, leaky ReLU. You can replace ReLU and you can use maybe softmax or other activation function and you can compare the result. Then you'll be doing, weights will be the same, only you are doing what? Changing the activation function.
Okay, okay.
Excuse me, sir.
Yeah.
Thank you, sir.
These are hyperparameters are there, like width of the hidden layer, length of the hidden layer, number of hidden layers, number of neurons per hidden layer, and what type of activation functions are there. There is no hard and fast rule that these many are used, but only just trial and error methods.
There is no hard rule, Nowadays, nobody is designing their own deep learning model also, madam. There are 6 to 7 very popular models are there. People are testing with them only.
Okay.
Even people are not building their own. Already existing models are there. I don't want to name them, but you can go through Google. So at least people will go through the Google so that you will be knowing those models. So people are testing with them only.
Okay.
So that is the thing.
Suppose if we want to develop one.
Yeah, you can develop using Keras or maybe Python with the help of that. You can develop. You can create your own model.
For example, if in our college, particular college, developing IDs and all, for how we have to develop facial recognition and all. So we have to train data with our college staff people, no?
Yeah.
Then how can we use the already developed models, trained models?
The trained models are available freely. You can give to them. See, trained model means what it will have? It will have only what? The hidden layers and the output. Everything will be there. So your input you are giving.
That is like only testing the data, no? But not training the model.
No, that part also you have to do training, madam. Training means you have to feed all your images. Maybe in
okay, in their input we have to give our input.
You maybe there are 1,000 faculty are there. So 1,000 is your training set.
Okay.
So what you have to give is first initially you give 800 images. Then give input as one from these 800 images. Then it should recognize. Then remaining 200 are there. Next time you give an image from that remaining 200, it should say that it is not recognized. So with your data itself, you say some of them, most of the 80% of the data you use training, and remaining 20% also you can use for testing. So the testing data should not be a training data. So that whenever you are giving a testing data, it should say it is not recognized.
So that means we don't need to bother about the code.
Yeah.
So whatever the code is available, we have to just replace our input data.
That code and you have to train.
Pardon, sir?
You have to, code is there, madam. Already you can go through Python or anything. That code is there. You can go through that. You just open the Python, then you will be learning many things.
Okay. Thank you.
Is there, OpenCV is there. Our people are doing with MATLAB also. So, but I don't encourage MATLAB, though I worked a lot on MATLAB. But now you have got the open platforms, so better you go with them.
Okay. OpenCV is better.
Yeah, because that is open, no?
Okay. Thank you, sir. Thank you.
Hello, sir.
Please,
sir,
madam,
can deep learning be used with unsupervised data also, unsupervised mode of learning?
Yeah.
But what need to be done there in the supervised mode where we have labeled data there, we can easily apply it.
Yeah.
What changes need to be there if we have unlabeled data?
No, unlabeled data, because anyway it derives features, madam. For example, you have given 1,000 images of car.
Yes,
and
sir.
you have given 1,000 images of dogs. You have given 1,000 images of horses, different dogs. Then what it does by learning it will say, oh, these 1,000 belongs to one, because maybe comparing the leg size or maybe overall size, maybe face size and everything. So that means it will categorize these 1,000 as what one and those 1,000 as what other.
Okay, sir.
So whenever you give, then it automatically does.
Okay, sir. Because in one of the session, Jyoti sir said we don't need labeled data in case of deep learning.
Yeah, that's what I'm saying. No need. Now here also it will learn itself.
Okay, sir.
Because if I say without labeling, for people it will be difficult to understand deep learning. So I have gone with the supervised, but with unsupervised also assume that I have not labeled it as a dog, I have not labeled it as a horse. Can't you recognize that these two are different?
Yes, sir.
You will recognize, but you don't label it as a dog because you don't know that is a dog. You will say this is different from that is different.
Okay.
Maybe you are listening Tamil movie and also you are listening maybe Malayali movie.
Yeah.
But you don't know that is a Tamil, you don't know that is a Malayali, but after listening what you will say, oh, this is in some language, that is in some language.
Yes, sir.
No labeling, that is what. Madam, try to always think of what day-to-day examples, then the concepts will be more clear.
Okay,
Once
sir.
you are able to do, machine can easily do.
Yes, sir. Okay, sir. Thank you very much, sir.
Sir, hello.
Hello.
Yeah.
These neural networks are useful for clustering also?
Yeah, you can go ahead. No problem. But you need to work on that. Because I cannot say no.
Okay.
I think so. It's over now because I've got other meeting. So any doubts you can mail.
Yeah, thank you, sir. Thank you very much. Participants, still anybody having any doubts? Right. Sir, thank you, sir. Thank you very much, sir.
Thank you, Oblesh. But anyway, with short notice, I could able to fulfill.
Yeah, thank you, sir. Thank you very much, sir. In this, main speaker is the note.
Yeah, no problem. Right.
In such case, you given very good help, sir. Thank you, sir. Your session is very informative. Most of the participants have given very good feedback, sir. And you started with the computer vision basics and what is the image and what is the importance of bias, what is the significance of bias, what is the significance of neural network, how to train, and everything you clarified with a simple example, sir. Even one of the comment, layman also easily can understand. One of the participants given that feedback. So yes, sir, your talk is easily, and layman also can understand all the concepts of deep learning and all. Thank you very much, sir.
Yeah, thank you, Oblesh.
Sir, Vijay sir,
all participants.
mail ID, sir.
Yes, ma'am, I will forward, ma'am. All the participants, a small request is that already I sent a link for the code previous sessions. Once you go through the groups, WhatsApp group and Telecom group, access the code and try to execute that. Afternoon session, as usually, as per schedule, it will start by 2:30.
Hi, can you put that in the Google Drive or somewhere? I couldn't join the group. It said it was full.
Complete code, what I shared you Google Drive link only, ma'am.
Okay, thanks.
Sir, can you put PPTs also in that drive?
Yes, sir. Yes, sir. Actually, Jyoti sir today is not connected.
No, current session, today's session PPT also.
Yes, these slides I will collect from the screen and I will forward to you, sir.
Okay, sir. No, please include in that Google Drive so that everyone will get, na?
Yes, that's what every slide, every day slides will be copied in a drive. That's what the link I shared to you. Please
okay.
Sir,
thank you, sir.
Can you please again send the attendance link?
Sorry, sir, your voice is not here. Anything else?
Sir, attendance link, please.
Yes, already shared you, no?
So can you again send in? So please again send the link in chat box.
Yeah, wait 1 minute, sir. Wait.
Okay, sir. Thank you.
We will give you enough time for filling your feedback, sir. No problem at all.
So feedback has been shared. Kindly fill.
Sir, full name of professor?
Dr. V. Vijay Kumar. I'm typing here. Right. Sir, Vijay Kumar, sir. Vijay Kumar, sir. Yeah. All the participants. Yes, sir. With your permission, I will close the meeting, sir.
Yeah, please.
Thank you, sir. Thank you.
All. Right. Have a nice day.
Thank you, sir. Thank you very much. All the participants, those who will feedback, please leave the session.
Thank you, sir.
Thank you, sir. Thank you very much for your cooperation. Okay, thank you once again. Thank you all the participants. fill the feedback and leave the session. Thank you. If it is over, I'm closing the meeting. Thank you.